You're drifting through space, searching for a new frontier for humanity, when suddenly you stumble upon a cosmic giant, a black hole lurking in the vastness. Would you dare to explore its depths, or would you retreat, fearing its gravitational grip? Welcome, fellow cosmic adventurers, to an odyssey into the mysterious realms of black holes. From Einstein's theories to the far reaches of space, we're about to uncover the secrets of these celestial enigmas and delve into the captivating science behind their existence. But brace yourselves, for the journey ahead is nothing short of extraordinary. We'll address burning questions. What fate awaits those who enter a black hole? Is escape possible, or is oblivion inevitable within its dark embrace? So fasten your seatbelts and get ready for a thrilling voyage through the cosmos. Are you prepared to unlock the universe's mysteries? Let's plunge into the cosmic abyss together. And remember, share your thoughts on black holes in the comments below. Would you brave the unknown, or do you prefer to observe from afar? Let's ignite a cosmic discussion. And if you crave more mind-expanding space adventures, smash that subscribe button. Picture yourself on the sun, feeling almost 30 times heavier than on Earth due to its immense gravity. Now imagine squeezing 4 suns into a space as small as a room. What would happen to gravity there? It's like a giant cosmic vacuum, a black hole where even light can't break free. You can't spot it directly, but you can sense its presence by the energy bursts it releases, known as Hawking radiation, named after the legendary physicist Stephen Hawking. Hawking once proposed a fascinating idea. Could black holes act as gateways to other universes? If you dared to journey into one, might you find yourself in a whole different reality? Every black hole has a boundary called the event horizon. Once you cross it, there's no turning back. Beyond this point, stars appear to dance around a menacing dark sphere. As you journey towards a black hole, gravity grabs hold of you, yanking you faster and faster. Here's the twist. The nearer you come, the more gravity stretches and warps you. If you descended headfirst, your feet would feel a much stronger pull than your head, elongating you like a piece of taffy. The majority of black holes we've discovered are stellar, roughly 9 miles wide and as massive as 20 suns. Approach one of these, and you'd be ripped apart long before reaching the point of no return. But set your sights on a supermassive black hole, millions of times heavier than our sun, and the scenario shifts. Here, the gravity would tug on you uniformly, keeping you whole as you pass the threshold. And if you're curious about where to spot one, you won't have to search too hard. There's one smack dab in the middle of our Milky Way galaxy. Fortunately, it's a whopping 165 quadrillion miles away from us and won't swallow up either the sun or the planets. But hold off on packing your bags just yet. Crossing the event horizon marks just the start of the journey. At the heart of the black hole lies a gravitational singularity where density reaches infinity. You'd be crushed into that center and meld with the black hole. You wouldn't be able to share your adventure with anyone. Yet, to an observer outside the event horizon, the scene would appear quite different. As you plummeted into the black hole, they'd witness you slowing down, growing fainter and redder. Ultimately, you'd seem to freeze, never actually reaching the event horizon. This occurs because, at the event horizon, space and time swap their roles. Time halts while space continues forward. You wouldn't be able to turn back or escape the black hole any more than you could travel back in time. Even if a black hole were to eventually fade away, releasing all the stuff it had swallowed, including you, figuring out if those bits were once part of you, would be impossible. Stephen Hawking had a clever idea for this conundrum. He proposed that information about you isn't lost, but stored in other universes with their own stories. In one universe, you might fall into a black hole. In another, there might not even be a black hole. From outside the event horizon, there's no way to be certain. Picture this, crossing the event horizon into a black hole. In your reality, you might be okay. But if by some twist you ended up in a universe where the black hole never came to be, you'd carry on living, just in a different dimension. There'd be no way back to our universe. With millions scattered across space, a mishap creating one, what if Earth found itself being sucked into a black hole? Would we make it through, or would we end up like strands of spaghetti? Just 3,000 light-years away lies a black hole visible without any gadgets. Thankfully, we're far away enough to dodge its gravitational pull, but there's no shortage of them out there, around 100 million just in our Milky Way. These leftovers form when really big stars collapse inward on themselves. You've got your regular stellar black holes, about 16 kilometers wide, hanging around quite often. Then you've got the supermassive ones, as wide as our whole solar system and weighing more than 1 million suns put together. One of these behemoths, Sagittarius A, chills out at the heart of our galaxy. So how close would one need to be to cause trouble? Well, even a tiny one, as small as a pinhead, could be a big problem if it got cozy with Earth, all thanks to its super dense mass and crazy strong gravity. Whether we'd make it or not would depend on if we crossed the event horizon, the point of no return for the black hole. Once you're past that, you'd need to warp faster than light to get out. Good luck with that. If Earth got too close to a black hole, things would get messy fast. The side facing the black hole would start getting yanked towards it. Our atmosphere would get sucked up, and big chunks of Earth would break off and fall in. If Earth ended up in the black hole's orbit, we'd have another problem: tidal heating. The crazy strong and uneven gravity from the black hole would keep squeezing Earth, making our planet's core heat up like crazy. This would set off earthquakes, volcanic eruptions, and killer tsunamis, a real recipe for disaster. Eventually, Earth would start getting stretched out, a process called spaghettification. But trust me, it's not as tasty as it sounds. Picture yourself as a superhero trying to face off with the black hole. Your arms would feel the pull way more than your feet, making you stretch up and squish in. Let's just hope your superpower is super stretchy. All right, space explorers, it's been a wild ride diving into the world of black holes. From the mind-bending concept of spaghettification to the intense gravitational pull, it's clear that these cosmic phenomena are no joke. But fear not, because delving into the mysteries of space is what we live for, right? Even when things get a little spooky, there's always something new to discover and learn. Who knows? Maybe our exploration of black holes will unlock secrets that change our understanding of the universe forever.